In this example, we want to prove some properties of the trace. Remember that the trace of a matrix is the sum of the diagonal elements. So we're going to write A as little a ij and B as little bij. So the diagonal entries of A plus B are AII plus BII. Therefore, the trace of A plus B is equal to the sum from 1 to n of AII plus BII, which is the sum of the AIIs. We can break the sum up, plus the sum of the BIIs. This first sum is the sum of the diagonal entries for A, so this is the trace of A. The second sum is the sum of the diagonal entries for B, so that's the trace of B. So that's the proof of the first property. Next, the trace of alpha A is equal to the sum of the diagonal entries of alpha A. So this is alpha times AII, which happens to be equal to alpha times the sum of the AIIs, and the sum of the AIIs, plus equal to alpha, the sum of the AIIs is alpha times trace of A. And so the trace of alpha A is equal to alpha times the trace of A. Finally, the trace of the n-dimensional identity matrix is the sum I from 1 to n of the diagonal entries of that identity matrix. But it turns out the diagonal entries of the identity matrix are all equal to 1. And what happens when we add 1 to itself n times? We end up with n. And so this proves the three properties of the trace that we were worried about.